Welcome back to the YouTube channel me.u. The class 10 topic, chapter 1, real numbers. In this video, the last topic, decimal expansion of the rational numbers will be explained and the exercise 1.4 will be solved. The last part of chapter 1 is the decimal expansion of rational numbers. You studied already in class 9 that is by looking at the decimal expansion of a number we can identify whether the given number is a rational number or an irrational number. Now, for an irrational number, we have non-terminating and non-repeating decimal expansion. Whereas for a rational number, there are two cases. Either it will be terminating decimal expansion or non-terminating and repeating decimal expansion. Now in this topic, we are discussing about the decimal expansion of rational numbers. There are two cases, right? So by looking at the denominator of the fraction p by q, we know that every rational number can be written in the form of p by q. So by looking at the denominator q of the rational number p by q, we can classify whether the given fraction has a terminating decimal expansion or non-terminating repeating decimal expansion. So for that one, we have a theorem 1.6. Let x equals p by q be a rational number such that the prime factorization of q, that is the denominator, is the form 2 raised to n times 5 raised to m, where n and m are non-negative integers. Then x has a decimal expansion which terminates. So when the denominator of the p by q, the denominator of the fraction is of the form 2 raised to n and 5 raised to m, the prime factorization of the denominator is of the form 2 raised to n times 5 raised to m. That means the factors of 2 and 5 only. Then the fraction has a decimal expansion which terminates. Now we can discuss through few examples. So first one, 21 out of 8. We can write the denominator as 21 upon 2 cube. Now, according to theorem, the denominator is of the form 2 raised to n 5 raised to m. 5 raised to m, here m is a 0, right? So there is no 5. So it is not necessary that we need both the number factors 2 and 5. Either 2 only or 5 only or the combination of 2 and 5. So here we have only 2. So it has a terminating decimal expansion. Now to find the decimal expansion, it is not required to divide 21 by 8. We have a simple method to find the decimal expansion when it terminates. So what we'll do is we'll make the pairs of 2 and 5. So there is no 5 here, and what we'll do is we'll multiply. So there are 3 2's are there, right? So we'll multiply 5 cube in the denominator and in the numerator. So we'll get 21 times 125 divided by 2 times 5 the whole cube. We know the property of the exponents. So a raised to m times b raised to m is equal to a times b the whole raised to m. Means, so 21 times 125. So it is 2625 upon 2 times 5 is 10. 10 raised to 3 is 1000. Now it is easy. So we can write it as 2.625. Okay, simple, right? Now another question. 9 by 15. By factorizing the denominator, we'll get 9 upon 3 times 5. So we'll get a 3 here, but you can cancel out, you can simplify this fraction because 3 is a common factor in the numerator and the denominator. So after cancelling the numerator and denominator by 3, you will get 3 upon 5. So the denominator is 5 only, so it terminates, the decimal expansion terminates. Now to find the terminating decimal expansion, here we need to make a pair of 2 and 5, pairs of 2 and 5. So we'll multiply 1 2 here, we'll multiply 1 2 here, so we'll get 6 out of 10, which means 0.6. Okay. Now another example, 3 out of 7. So here you can see that factor of the denominator is 7, not 2, not 5. So in this case we can say it has a non-terminating repeating decimal expansion. Okay, so by looking at the denominator you can identify, you can find out whether the decimal expansion of the fraction is repeating or terminating. Now we'll do the exercise question so that the concept will be more clear. Now let's solve exercise 1.4. The question number 1 and 2, I'm doing it together because 2 is a continuation of question number 1. Question number 1 is, without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion. And question number 2 is, write down the decimal expansions of those rational numbers in question number 1 above which have terminating decimal expansions. So in question number 1, if it is terminating, if you identify that it has a terminating decimal expansion, you need to find out. Okay, so we can solve one by one. First question is 13 divided by 3125. This can be written as, we can factorize the denominator. So 3125 is 5 to the 5 to the power 5. So it is 13 divided by 5 to the power 5. So the denominator is of the form 5 raised to m, right? All the factors of the denominator is 5 only. So if the denominator, the factors of the denominator is only 5 or only 2 or the combination of 2 and 5, then the fraction will be terminating. So it has a terminating decimal expansion. Terminating. Okay, because the denominator is of the form 5 raised to m. Since it is terminating, we need to find the decimal expansion, and that is the question number 2. So to find the decimal expansion, it is very simple. You don't want to divide 13 divided by 3125. So we'll make pairs of 2's and 5's in the denominator. So what we'll do is 13 divided by 5 to the power 5. So there are 5 5's, right? So we'll multiply the same number of 2's here. So 2 to the power 5. And you know that in a fraction you can multiply the denominator and numerator with the same number. So we'll multiply 2 raised to 5 in the numerator. So the fraction won't change. So it is 13 multiplied by 32 divided by, using the exponential law, you will get it 5 times 2, that is 10 to the power 5. So which means 13 times 32, it is 416 divided by 5 zeros, 1 2 3 4 5, and it now it is easy to convert into decimal expansion. So it is, there are 5 zeros, so there should be 5 decimal part. So it is 0.00416. Clear? Next question, 17 out of 8. We can write this one as 17 upon 2 to the power 3. Now you can see the denominator is of the form 2 raised to m. So since the denominator is of the form 2 raised to m, it is terminating. Since it is terminating, in question number 2, the question is to find the decimal expansion. To find the decimal expansion, we'll make the pairs of 2 and 5. So the 5 is missing in the denominator, so we'll multiply the required number of 5's. So it is 2 raised to 3. So we need 5 raised to 3 here. The same 5 raised to 3 will multiply in the numerator. So it is 17 times 125 divided by 10 to the power 3. So what is 17 times 125? Is 2125. 2125 divided by 1000. Now it is easy. It is 2.125. Okay. Next question. 64 divided by 455. So on factorizing the denominator, you will get the factors of the denominators are 5 times 7 times 13. 5 times 7 times 13 equals 455. And the denominator is not in the form of 2 raised to m 5 raised to n. So there are numbers other than 5 and 2. You can see 7 is a factor and 13 is a factor, and it is not common in the numerator and denominator. 64 is not a multiple of 7. 64 is not a multiple of 13. You cannot cancel out. So the denominator, since the denominator is not in the form of 2 raised to m 5 raised to n, it has a non-terminating repeating decimal expansion. Okay, it's very simple, right? Now next question, 15 upon 1600. So on factorizing the denominator, you will get denominator is 2 to the power 6 times 5 square. So its denominator is in the form of 2 raised to m times 5 raised to n, because only 5 and 2 are the factors of the denominator. So we can conclude that it has a terminating decimal expansion. Terminating decimal expansion. Now in question number 2, we need to find out the decimal expansion. So 15 will make the pairs of 2's and 5's. There are 6 2's and 2 5's. So we need 4 more 5's to get the pair. So 2 to the power 6, already we have 5 square. We'll multiply 5 raised to 4, so that we'll get 6 5's also. There are already 6 2's. So we'll multiply 5 to the power 4 in the numerator also. So it is 9375 divided by, so there are 6 2's and 6 5's. So we'll get 10 to the power 6. That means 6 zeros. 6 0 means we need 6 decimal parts. So 0 point, already there are 4 digits. So 0 0 9 3 7 5 is the decimal expansion. So without dividing, you will get the decimal expansion. Now the fifth question, 29 upon 343. 29 upon 343. 343 is the cube of 7. So it is 29 upon 7 cube. So the denominator is not in the form of 2 raised to m times 5 raised to n. 2 is not a factor of the denominator, and 5 is also not a factor of denominator. So we can conclude that it has a non-terminating repeating decimal expansion. Okay, now we'll move to the next question. 23 divided by 2 raised to 3 times 5 square. So he's already, the denominator is in the factorized form. The denominator is of the form 2 raised to m 5 raised to n. That means it has a terminating decimal expansion. Terminating. Now, since it has a terminating decimal expansion, for the question number 2, we'll find the decimal expansion. So we'll make the pairs. 23 divided by 2 cube times 5 square is already there. So we need one more 5 to make the pair with the 2. So we'll multiply that 5 here in the numerator also. So 23 times 5 is 115. And there are 3 2's and 3 5. So we'll get 10 to the power 3. So 1000, right? 3 zeros. So we need 3 decimal part in the number. So we'll get 0.115. Next question. In this question also, the denominator is given as a factorized form. Is already, the factors are given 2 square times 5 raised to 7 times 7 to the power 5. It is not in the form of 2 raised to m 5 raised to n, because we have an extra factor 7. And we cannot cancel out all the 7. 129 is not a multiple of 7. So we cannot cancel all the 7 to the power 5. We will get an extra factor other than 2 and 5 in the denominator. So it has a non-terminating decimal expansion. Non-terminating and repeating. Non-terminating, repeating decimal expansion. Next question. 6 upon 15. The denominator can be factors 3 times 5. Actually, we have a 3 extra in the denominator, which is not in the form of 2 raised to m 5 raised to n, but this 3 is a factor of the numerator also. You can cancel out 3. So 6 is 3 times 2, right? 3 and 3 cancelled out. So we'll get 2 upon 5. Now the denominator is only 5, so it is terminating. Now for the question number 2, we can find the decimal expansion 2 upon 5. So you can multiply 2 in the numerator and the denominator. So we'll get 4 upon 10, which equals 0.4. We need the same number of 2's and 5's in the denominator to convert into decimal expansion. Next question. 35 upon 50. So the denominator can be written as 2 times 5 square, right? So it is of the form 2 raised to m times 5 raised to n. It has a terminating decimal expansion. Terminating decimal expansion. For the question number 2, we'll find out the decimal expansion. So to make a pair of 2's and 5's, we need one more 2 in the denominator. So we'll multiply it. 35 times 2 divided by 2 times 5 square times 2. So it will be 10 square. So 70 upon 10 square. So 10 square means 100. 70 upon 100 is 7 upon 10, 0.7. And the last question of this one, 77 upon 210. 77 upon 210 can be written as 21 times 10, right? 21 is 3 times 7. 77 upon 2 times 3 times 5 times 7. Now there is a 7 in the denominator and there is a 7 in the numerator. 77 is a multiple of 7, so you can cancel out by 7. So you'll get 77 divided by 7 is 11. 11 upon 2 times 3 times 5. Still there is a 3 extra here other than 2 and 5. If you get any factor other than 2 and 5, so it is a non-terminating repeating decimal expansion. So this fraction has non-terminating repeating decimal expansion. Hope the concepts are very clear. It is very simple. Okay, so we'll move to the question number 3. Now the last question of this exercise, question number 3. The following real numbers have decimal expansions as given below. In each case, decide whether they are rational or not. If they are rational and of the form p by q, what can you say about the prime factors of q? First question is 43.123456789 stopped, right? Now it is terminating because it stopped there. It is terminating. So what about all the terminating decimal expansion? It is rational. All the terminating decimal expansion means they are rational numbers. Okay, they are rational numbers. Now what about the denominator of the fraction? All the rational numbers can be written in the form of p by q. Then what about q? So the prime factors of q, the prime factors of the q will be of the form 2 raised to m times 5 raised to n. Only 2 and 5 will be the factors of the denominator. That is the conclusion of the denominator of the fraction. Next question. 0.1201200120000120000. So in each time 10 is increasing and there is a dot 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 means it is non-terminating. It is non-terminating. And is any number repeating? Actually, there are digits repeating, right? 1 is repeating, 12 is repeating, but the pattern, it is not a block. A block is not repeated because the first block is 120, and the second block, you can see the first block is 120, and the second block is 1200, and it is 12,000, right? So the blocks are not the same, they are different. So the blocks are not repeated. So it is not repeating, non-repeating. So what about the non-terminating, non-repeating decimal expansion? So they are irrational numbers. Irrational. So this is an irrational number. Now next one, third case. So you can see a bar on the top of the decimal part. So the bar means that block is repeating. So actually it can be written in the form like this: 43.1, 2, 3, 4, 5, 6, 7, 8, 9. Again 1, 2, 3, 4, 5, 6, 7, 8, 9. Again 1, 2, 3, etc. It will go like this. That means the bar on the top of these digits. That means it has a non-terminating but repeating a block. This block is repeated. You can see that this block is repeated. So it is a non-terminating repeating. What about the non-terminating repeating decimal expansion? It is rational. Now every rational number can be expressed in the form of P by Q. Then what will be the form of Q? The Q will not be of the form. It cannot be in the form 2 raised to m, 5 raised to n, because it is repeating. When it is repeating, that means it is not in the form of 2 raised to m, 5 raised to n. There can be some other prime numbers as the factors of the denominator. Okay. So that's all this chapter, chapter 1, real numbers. Thank you for watching the video. Hope you understood all the concepts of chapter 1. Have a nice day.